With this tutorial, I'm going to go over the action classes list that you can find in the action settings. And if you haven't already figured out how to define the different methods in here, this will be a useful tutorial to help you understand what goes on and how to format it. By default, your eco action object will have a start event, which is a native event that is triggered when an action object is first rezzed around other breeds, in which it sends that information, the following parameters, to all of the breeds that are present. Or if you res a breed object and there's an action object around, the breed object requests the start event from the action object, and it will relay the string of methods that are defined under the next parameter. And to go into all the detail with all the different methods, events, and callbacks, the expressions, and the different attributes, I'm going to be going back to the EcoWiki, the documentation page that you see here in front of me. Here you'll be able to find, under the reference section, information on how to define the action classes list based on the different parameters that you're giving to it. First you have the settings and features section, and that goes through a wide variety of different settings that you'll find in the breed and action objects. You go into the Eco Core section, and this all defines the different ways that the different core functionality handles based on its protocol, what it does, and why it does it. So it talks about how skins are implemented, how breeding, hunger, growth, movement, prim animations, rebuilding your pets, as well as the event flow that is defined in the action classes list. All these are built in, but then you have the event flow, which is where you are defining the different methods and events within this action classes list. Now, to just briefly explain what this does, when a new breed is rezzed around an action object, it'll say hello eco, and a hover text will be applied just one time over top of it saying eco breed. In both of these methods, you can apply different types of expressions, such as saying its name. So you would do something like this, and that would say hello, and that would be its own name. However, if you wanted to just say, hello to the owner using the owner's Second Life avatar name, you would use something like this. Now, you could also do this with the hover text. Perhaps you would like to say its age, and you would do a my age expression like such. But remember, this is only going to set the text of its age just the one time. If you wanted to do updating text, you would actually have to bind a timer event for every so often. That would be 10 seconds, and to call back to a custom event where you can call it a callback as well. This callback you have to define under the next series of parameters. Let me go to the EcoWiki and move you along into the classes section, where it tells you how to format these lists. It doesn't matter if you drop it down to the next line or keep all your method strings on the same line, but it's a strided list, a series of event and methods, and separated by commas. So you'll have a method string that is just one string, which means it's surrounded by quotes, and separated by a comma from the event identifier itself, and also separated from any other event identifiers that you see subsequently. You can also format these lists using built-in Second Life values, such as string my event and naming it, and identifying the the method string using a simple second life string value, and then just dropping the static values here within the list. Now, the most important part of this website is the methods section, where it will show you all of the different methods that you'll find useful for your breeds, such as the different actions and communications. There are event flow methods, such as binding new events, or killing the object entirely, filtering out different values, turning an event on or off, pausing the event for a period of time, or toggling a specific callback or event. Then you could also unbind any events that you do bind. You have all the communication ones, such as setting the text, or saying things in local chat, or sending an instant message to a specific avatar. But you can also create menus with a variety of buttons, and as well as a text box, which is an input field for where the user can put data into the object. And by clicking on these, it'll open up the examples for each one. For this, if you were to have under the start event a text box drop down, and owner key expression right here would be replaced with the owner's key, and you would have a message within the menu, the drop down menu. But it also gives you a input field where you can set the name. I'm going off of this example, but this could give you a variety of different options as far as allowing user input, changing the name, the family, or setting a variety of different properties that are user defined, such as its level of happiness, or where its home is, or different types of features, things for it to look for. But in this situation, in this example, I had it call back to a change name event, which you see here is on the next line after the comma. Change name will refer to the methods that are defined beneath it. What this does is it calls the val method, which changes the my name value to whatever was typed into chat. Well, it's an input field, but it would change the name to whatever is input into that field, and then it will say that name in chat. Now, that's just a simple example of how to use the text box, but that's just a good way to understand how these methods are set up with the triggering the callback events that can define other functionality. And then, of course, down here further, we have ways to manipulate the different data that's applied to it, such as setting a user-defined property, where we have, if we want to create health for it, because there is no built-in health or any values called damage or any lists called friends, you can create them though, and you would do this by using the prop method. And setting it like this would set the health to 100, and if it's not already created, it will set it to 100. If it is already created, it will still set the health value to 100. I did this in a series so you could kind of understand how each thing works. I later set damage, a value called damage, to 5, and then I took it down even further, and I reduced the health by the damage. So if it was 100 and I reduced it by damage, it would take 100 minus 5, and in this scenario, health would now be 95. You could also do numbers as well, so property health plus 5 would increase it back to 100. However, if you do not supply that second value separated by the comma in the method, it would remove the health entirely. So you would have no value called health. Another good thing about this is when you do set these values, you could use them in your um, in your text or say or whatever, you could use them here and as an expression, so you can pull that information later and say you want to do health. Well, in this case, you would just type it out like that. So hey, health is now as it were 100 minus the 5. It would then show as 5, but you would also have to apply these properties. So perhaps you would do something along the lines of from the very beginning, setting a health at 100, and then maybe setting your damage points to 5. Then you could, just for a simple way of handling this, let's say you do a collision event, which is called collide, and maybe you want it when it collides with an object called bullet. It goes to a special callback, maybe we call it collision. So this now binds a collision event, so when a bullet collides with it, it triggers an event called collision. So we define collision with the following properties. We're going to use the method health minus damage. So going back into here, we can just set health minus damage, and every time a bullet collides with with a breed object, it will reduce the health by 5 points, and the text would update and show the health, but it'll only do that every 10 seconds. So if you wanted to immediately show the stats after a collision, you could use the built-in toggle event, which the toggle would toggle a you would want to toggle the event by its identifier. So you would do something like that, and it would immediately update the stats after it was struck with a bullet. Okay, so that's one example, and I just wanted to move through this and explain more about the different methods that are included here. When you're setting animations, you first have to define them from your EcoBreeds page. So you click on this, and you would want to find the species that you're currently working on, and I'm working on the dog. You have the different animations that you would define here. Right now there's only one animation. If you wanted to create a new animation, you would give it a name, whether or not it's going to repeat or delay, and then you would set the parameters here. And the parameters would look something like this, where you have you're changing a specific prim by its number. For this case, it's resizing the prim, moving it using the position method, rotating it to a specific rotation, and setting it to a specific type of prim with the appropriate cuts and tapers and other like hole sizes and shapes. So simply calling that from your methods, you would need to just use set. So in this case, if under those parameters I just had color prim number 1, -1 would indicate all sides, and you would have the option of 2 values. You can just set just the 1 value, and it would just set it once, and it would set the first prim to negative to all sides. It would turn it black, but in this case I gave it a second parameter, where after a designated delay it will turn all white. But setting it is as simple as just calling set and flash, because under that circumstance I would define the animation as flash, all lowercase. Okay, and if it was repeating, you could later unset it using the unset method. So let's say under the action classes list, when it starts, I bind a touch event for just the owner to unset the animation but then immediately set the flash animation. So on start, it would immediately start flashing the main prim from black to white, and if the repeat was on and set to infinite, it would just continue to repeat over and over until the owner touches it, which it calls back to the unset anim method, event, and that would call the unset flash. So this is how you would set and unset an animation in a basic simulation. Okay, so we'll move on. In another tutorial, I'll get into more advanced ways to handle your dialog menus, as well as the text box, and integrating the two, such as supplying a button that when let's say you want to change the name, when you touch it, and it gives you a variety of different options like show the statistics, or tell it to come here, or start wandering, or stop, or go home. But you could also have a button that says change name. Click change name, and it refers to it gives you the callback to text box, where under that simulation it would call the text box, which would drop down the input dialog, where they would enter a name, click send, and that would send the message that was supplied to this callback, at which point you would change the value and maybe say it in chat. Basically, to help you understand how everything works in this setup, here is where you'll find what values are expected for each of these methods. So as I showed you with set, you have to set at least the first value to the name of the animation that you defined on your EcoBreeds page. But you also, as you see per the brackets, you can put an additional value here. So you would separate it by a comma, and you would type true, T-R-U-E. And true would save that, so that if the pet is ever rebuilt, it will immediately start that animation from the beginning. And this could be extremely useful for accessories and other things, but in this situation, we're just like flashing the main prim with color, black and white, back and forth. Let's move on to some other really important methods. The filter I'm very particular to. I really enjoy writing with this method because it allows you to filter out different types of functionality, such as in the start event, I defined a bind, a touch that all people can touch. And when all people touch it, it calls the custom event called check. Now check is defined with a filter saying, alright, if the toucher is the owner, so it would be the name of the person who touched the breed. If it equals the owner, it will continue on to the next filter if you apply it. As you can see, the only value that you need is the condition, and this would be your condition. So all of this here is not necessary. If all of this was, if you didn't have any of this here, it would stop the event flow right here if the toucher was not the owner. But if it was the owner, it would move on to the next method, and it would say the message or any other functionality that you have after that. However, in this condition, I have a false callback, and my false callback means it's not the owner. So if it's not the owner, it has a way to continue with the event flow, but it will skip over this, and it will skip the rest of the conditions and callbacks that you supply within the filter. So it moves on to, if it's not the owner, it'll move on to is false, and it will say in local chat that you were not my owner and the name of the person who touched. Then if, let's say, the toucher was the owner, it would pass this, and it would move on to the next condition, where you have, if the toucher key, if that person's that touched, if their key equals group, which is another attribute that filters out whether or not this person is in the same group as the breed object. So if the toucher is in the same group, it will pass up this, and it will say you are in fact my owner because it passed the first condition, and it would say that you are also in my group because it passed the second condition. But let's say it passed the first condition and it did not pass this because the owner is wearing a different group tag than the breed object. It would then say wrong. It would call back to wrong group. Wrong group would be defined down here where it says you are my owner, and then the person who touched name, but you are not in my group. So this is just a simple way for you to understand how this is set up using the filters with the different conditions and callbacks. And remember, there is no true callback, because if it is true, it will just pass and move on to any methods that are behind or after the filter is called. And I also show you how this would look if this exact script with only this functionality was defined in an LSL script. It's almost the same amount of characters, whereas I believe I checked this was like 210, this was 250 characters, so maybe just a little easier to write, but it's also much easier to define because you're able to visualize where everything goes and where you can supply different information based on the event that's being triggered. Without having to go through all of the operators and definitions and native Second Life functions. But we also have another way of handling the filter. You can create lists using the property method that I was just talking about. And using the property method, it will you can, let's just say from the start event, you define a property called friends, and you want to point to and make it a list and point to the end of that list. You would use the character n to define that it is at the end of the list where it's going to add excuse me, the values me and you, where after I supply this information, the list is now me and you. And we can use the friends list in as an expression, and use the operator, the up sign, where you can determine if, with the filter, if you is in the friends list. And by doing this, you would if you is in the friends list, which it is because we defined it, it would pass this filter and say that you was found in the list friends. Now if let's say we didn't give you, we put something else, it would call back to the false callback, and it would say that it was not found in the friends list. So, and similarly, I showed an LSL equivalent as to how you would create such a script in LSL. And for people that are programmers who understand how to write in Second Life code, you can see the difference in how you would be defining this, as well as how scalable this is, based on the ability to define them as an expression later on in other methods without providing global values, just by creating it using the property method. So I could go through every single one of these with you, but I'm just going to go through the most important ones. And since we did go over bind, I'd like to elaborate a little bit more on that. In here, you can set the type of bind, and you'll find these the bind types by going into the event section of the website. And in events and callbacks, you'll see that not only do you have the native events that are built into the code, such as when an object is born, when an object dies, when the food is consumed, the start of an action breed or object, an eco breed or an action object, or whether or not it's within water or outside of water, which there are actually several ways of detecting water within the code based on how you would like to define it in your event strings. But where we were going was the bind events, and in the bind events you have the ability to bind additional events, such as when an object is attached, when something collides with the object, when it's detached, or when it's when you click and hold for a period of time. You can define a hold, as well as if it interacts with land or it's interacting with water. Just like you have the water start and water end that are native events, you can also create very specific events with additional filters using this. But it also gives you events that are toggled when the object leaves a region, or if somebody sits, or if the object is in motion, or if it has stopped moving. But you also have these are the more common ones. You have timer and touch. Timer, you can set a time in seconds and also amend it with an R after it. So you would do like 5 seconds with an R after it would mean a random number between 0.0 and 5.0 seconds. And that happens for every time the event is triggered. So you will have the ability to, so it won't always be a random number. It won't just pick 3.2 seconds and continually occur every 3.2 seconds. You would have literally a random timer event being raised sometime between 0.0 and 5.0 seconds in this simulation. Now we have the touch event, which is also very popular. I've already shown you how to work that. You can use custom attributes for this, and I'll show you. It could either be the name of a person or an avatar's key, or you could use a custom bind attribute, which when you raise a bind method with the type value of touch, collide, sit, or unsit, you would have the ability to change. You could filter the values that will trigger the event, such as, let's just stick with touch. If I'm using the method, the bind method with the type value of touch, all would let anybody, including the owner, group members, everybody who touches it, to raise the callback. If you used group, the group would be, if the object has the same group as the avatar that's touching it, it would raise the event. If it's the owner, it would be an owner-only touch, or conversely, you would be able to do a not owner, which would be useful if you wanted to give two different menus, such as one menu for the owner and one menu that's not for the owner. You would define that here. Let's go ahead and bind bind the touch for owner and call it the owner menu. Keep in mind that you can have spaces as your callback, so you could do owner menu, right? I typically write with an underscore just because it's easier to copy and paste later. So if I were to have done this, I can always use it, later on without having to, copy over the whole thing. That's just my way of doing it easily. Owner menu, you would then, set your menu with the parameters. That would be an expression using the owner key with a message supplied here for the dialog, and then you would have a button equals callback. And what that would do, it would give, when I touch the button called button, it would send a callback. So if I wanted to have a button that was called say hello, and you would just, maybe write a special callback here for it, hello, and you would do something just like that. Now remember, you have a comma after every string value, not just every method, because if I wanted to do another event after that, such as if I wanted to clear the text, or I think just for use, hide text, we would have a button that says hide text, and when I click it, it will call back to hide. And now it would disable the hover text. But now remember, since it's on a timer and it's going to continue to do all this, if I wanted to really hide the text, I could add the fourth value to the bind, where I could have a callback saying remove text. So no, that's not a callback. This is a callback. This is a handle, and the handle would remove this whole thing when I call unbind. So I would unbind the bind that initially was supplying the hover text every 10 seconds. But this is an optional fourth value, as we were going over here in the methods section. Under here, as you can see, it's wrapped in brackets. That means it's an optional value. It does not need to be supplied. However, if it's not in brackets, it definitely needs to be applied, such as for val, you need to have an attribute and a value. Otherwise, the method will silently fail or cause unknown functionality. And just like any kind of formatting, if you don't format these things correctly, there could be issues. So it's always good to check to make sure that your formatting is correct, and that all of the values that you're supplying to it, whether they're expressions or attributes, that you're double checking to make sure that they are in fact being used, that they are spelled correctly with the correct capitalization of the letters. But while we're in the expressions section, I'd like to just to go over quickly where these different values are. I put here in red bold text that if you need to use a % character within your string, such as health is 100%. Well, if you were using the method that we were just talking about here, where is the health? Let's say I wanted to say health in text, health of 100%. If I were to put another % mark here, it would not know what to do with it, because if there is any, let's say health was never defined. If health wasn't defined, it would not know what to put there, so it would remove the expression that you see here and supply it with the undefined value that is supplied within the eco-breed objects themselves. So by default, it would remove this and say undefined. But if health is supplied, and I wrote it just like this, it would say the health number and then undefined after it, because percents are reserved for expressions. So you would have to use this as the Unicode, which is replaced in any text or message. So something like this, if your health was 100%, it would write it as literally this in text: health as per the text. So this string would then be converted to this over your object. Okay, back to expressions. We have a variety of different values that you can use within the different methods, and off to the right it tells you what type of value that these are, such as the hunger is an integer, your home would be the vector, the position of it, and you would also have strings and float values, so that you know what to expect when the values are being passed off through expressions. But you do have a variety of different types of expressions, such as ones that pull information from the action objects themselves. You have breed expressions, which are they'll tell you about the different breed values, such as its age, gender, its parents, the species, and other values that are stored within it. But then you have environmental values, such as the object's current height, the position, the current region name, the speed that it's traveling at, and the water height that is currently within that for that region. The water height's the same value for the entire region. We also have other expressions for interactions, such as action would give the action object's name or the description of the action object, as well as its position. But you can also retrieve a chat ID that this is being sent from a menu or a text box response. Chat message itself is only supplied via the text box, because you already have your callbacks defined for any button that's supplied in the menus. But you also have the name of the person who used the menu or chat box, as well as the position of that person from the last menu or the text box response of where they were. But you also get the owner's name, the owner's key, the owner's current position, if they are online or in that region or not. You also get the sitter name and sitter's key, the toucher's name or their key, the position of that person that touched. These are just different interactions that you're able to use those keys and strings within the object's core functionality or within custom methods. And speaking of custom methods, you can supply these to your extension scripts. If you make additional plugins for the EcoBreeds, you can use any of these to pass on to your extension and use that in the attributes. Now, you also have dynamic expressions, which are how we were explaining the health earlier. So for this case, we're setting happy as 100, and then setting a text saying happiness is, with the property surrounded in percent marks, and would display the text just like this. But you also have the ability to set the skin categories as an expression. So you have, if you had 3 categories, you had fur, eyes, and tail, and you had maybe 5 different furs and 5 different eyes and 10 different tails. When the object is first created, it only applies 1 from each category. So this would tell you which fur was picked, which eyes were picked, which tail was picked. But remember, these are user-defined categories, so whatever your category is named, lowercase or uppercase or whatever, you need to just define them here, the same as you define them on your page for defining the skins, which again is in the EcoBreed section. I'm going to move back down to the attributes because we were going over filter, and I wanted to show you that this is where you would find if the object is being filtered by if they're in the group or not in the group, if they're the owner or not in the owner. This is they're not the owner. This is the just a few attributes that you could use. You could also set static filters such as let's see, if in this case right here we want to filter, how about we do it, alright, so after the collision occurs and the health is reduced by 5, I want to set a filter, and we could even make sure that it toggles the stats, but we want to afterwards set a filter that checks the health. And if health is less than 0, or if it equals 0, or whatever the case is, we could supply we don't have to supply a callback. We could just add functionality after this. So if health is greater than 0, it'll stop here. Or if it's in this case less than 0, it'll also stop right there. But once the health reaches 0, we could you know, make it die. So now the object itself is going to die once health reaches 0. Or let's see, what else would we want to do in this situation? You could also define it a little differently, where you can do it separately, such as if health is greater than 0, it will basically end the series if I don't apply anything after that. But I could also use the false callback, and you know, and maybe just call you know, you could say die, or you could, you know, say, you know, something like this. You know, I like to be as specific as possible when I'm identifying my events. So it's going to die from lack of health. You know, let's just say, you know, at this point we could, you know, unset any of the animations that are occurring, or set an animation sequence where it falls to the ground, stops moving, falls to the ground, legs up in the air, or the eyes turn to X's, or it just buries in the ground and turns into a tombstone, whatever. I'm just giving some ideas, but in this case, I am dead. And what this does is, once the health value is less than or equal to 0, it will trigger the callback, health die, and that would just simply say I am dead. But again, you can be creative with this and do a variety of different things. I just don't want to run this tutorial into the ground with elaborate examples, because we can do that in other tutorials. I just really wanted to go over the majority of different methods and things that we could use, and I will be going into movement in another tutorial to be a little more elaborate on how to set that up, but that's here in the actions. And as you can see, you have a variety of different possible values. Move by itself, set with absolutely no value, will just set the object to non-physical and to its current position. So let's say you wanted to you know, put it something that if it detects when it's falling, you could you know, add a move this, and it would stop it where it's at, and maybe move it to another position using a different move method, or perhaps you want to to stop it in place. You want to move it to a specific object and just stop it. You would call an empty move method. Otherwise, you could supply a position using an expression, or you could enter the position manually in the vector format. But additionally, you have other options such as supplying an offset, and with just this as it is, move to owner position, it would move using a non-physical movement to the owner's position without any offset or speeds or any callbacks. But we could also use a zero vector, which would be this next part is your offset. And let's say you wanted to move it to the owner but not right on the owner. You wanted to move it within like a meter away or a random interval somewhere in between here. When you're doing wandering, for example, you would do action pose with a let's say if you wanted to do a 3-meter radius, you would do 3i and 3i. And the I is similar to random, where random picks a number between 0 and the number, in this case 0 and 5. I would be between -5 and 5, which is important for the offset because we would want it to move within a radius around it. Whereas if it was just +5, 0 to 5 plus or minus, and 0 to 5 plus, it was 0 to 5 this way and 0 to 5, 0 to 5 this way and 0 to 5 that way, it would only have this scope to move around and anywhere in between here. But with -5 to +5 and -5 to +5 on either axis, X and Y, would give you a complete radius to select from, which it changes for every time you call the move method. You also have the ability to set the type of movement behavior, and this is an attribute. The attributes are defined here under move. You have float, fly, hop, hover, jump, run, a non-physical one such as set pose and warp. Warp would be an immediate move to a specific vector. A set position would move in increments to that object or the vector that you're calling it to. But you also have more common ones like walking and swimming and flying, which these define the behavior of the movement. So it would actually change the vehicle physics of your object to allow it to fly or to float like a boat or to swim underwater and not breach the surface. These are just the built-in attributes that can also be defined by speed and frequency of movement based on how you define it in the breed object themselves. But by default, each of these are sufficient in moving around, regular average animals that aren't just zipping in all over the place or need to move too slow. But here's the next part of the movement method. In that movement method, we have, whoops, I keep passing it. In movement method, we have the fourth value, which is speed. You can set that to slow, which you would literally set it to the word slow, or medium for normal speed. I see that I wrote that wrong, but fast for 1.5 times the normal speed. But you would also have the ability to write in specific speed. So if you wanted to change the speed dynamically, maybe make it 20 if the default is 10, and 1.5 times by using fast would only be 1.5, so it would only bump it up to 15. But say you wanted to use 20 for this specific move, you could just type 20 here, and float values are accepted in this value section. But also you have an additional value called arrived. And well, we have that would be your callback that would trigger here the arrived callback, which would say that it's a success. It has successfully moved to the owner's position. And also, I wanted to point out that we've recently added a cross-region at the end of all of this. The cross-region filter, if you will, is whether or not it's going to allow the object to cross the filter, cross the region into another region. Basically, what it does is it takes the position plus the offset, and it checks to see if that's still in the same region. If it is still in the same region, it by default will allow it to go to that. But if it's outside of the region without this flag being set, which would be your sixth value, and if you don't need any of these, you can just set them all to null, N-U-L-L, null. But you could set the final flag parameter to true, literally T-R-U-E. And if that's set to true, it'll allow it to move into an alternate region. And this is helpful because we do things such as grid-wide tour guides and such like that. I've had airplanes that would take off from one parcel, fly a dozen or so regions south of my parcel, and land down in Abbott's airfield. And I would then later take off from there and fly back and land in my parcel, all the while doing different prim animations such as the propeller and the landing gear up and down when it's taking off, and it also used different movements such as one for fly and one for a ground object. So once it reaches the vector that's at the beginning of the runway, it turns into a walking ground vehicle, and would land on the ground and taxi towards the end of the runway, and slow down, brake, and do a U-turn, pause for a little bit, and take back off. And that's just a simple example, not necessarily simple, but I'll be running that tutorial shortly, showing how I did that. But that cross-region flag was really important for allowing it to move without outside of the region. So I think we've covered a good amount of things here. Other things such as if you wanted to animate an avatar, you have the animation method, where you would define the animation that's supplied in the breed object. That animation has to be in the breed object. So when you call this and you have, let's say, a dance animation called dance, it would play that dance animation, and you would give a duration. If you call just the blank method, it would stop it. But you could also set the number of the duration. So this would be in time in seconds for how long to play it. You would use -1 to continuously play it, and I believe by default. Yes, by default it is constantly looping, so you could just call anim dance and it would dance and dance and dance until you call a blank animation, which would stop all animations that have been applied. Okay, now further down you can see, and we'll go into in other tutorials, how to set up your prim animations and your skin methods based on your skin sets using the methods supplied here. I just wanted to also mention that you can use shorthand for this. So if you wanted to use the same color on prim number 2, 3, and 4, you would separate it using the vertical bar 2, 3, and 4, and then set your values accordingly. If you wanted to do all prims, you would use -1, just as if you wanted all sides, you would use -1. And you could do any number of prims for this. It could be 20 prims that all have the same value, which is useful for when you're supplying the same texture or color or other value to the entire link set or just specific prims. And it helps you write less and do more. Before I move on outside of the method section, I also wanted to mention that we do have ways to attach and to an avatar. I just mentioned how to animate your avatar, which will request a permissions request just the one time for the life of that object. So once it requests that permissions, it will never have to request it again. It will continue. If you use attach or later animation, it will allow you to just do the to run that simulation, but it only requests these when the method is being called. So in this situation, what would happen is when the object is first res, it will bind the attach and detach. The attach and detach events, and so when the object is attached, using the next method right here, which first would call the permissions request. When you accept, it would attempt to attach to the avatar, and it would raise the flag, the event that I created here, attached and detached, as this. It would say the successfully attached and successfully detached. But I wanted to mention, since we were on this, is that if you want to detach your objects, you have to right-click and select drop, and that'll allow it to drop onto the ground. And at this point, the reason why this is important to have a bound attach and detach event is so that maybe you can stop alternate functionality, such as the walking animation, or for it trying to move to different locations. You could stop it here, and then when it's detached, you can continue through that cycle here. And I think we've wrapped up the reference section, and I'll get into the API and extensions in another tutorial. If you need any specific information on all these, make sure to read the information and to check out any links that are supplied, so that you know when it says, for this example, the code is useful in the native dead event. Well, what is the dead event? You click on event and it'll tell you in the native events that dead is an event that's triggered when the object dies or an unauthorized copy or modification has been made. So based on what you just what you're looking at, that it does, that these individual things have more values or more information about them than what is supplied under their definition. Okay, so we've wrapped this up really well, and we've created a number of different examples. And if you need to find out how to do any more elaborate tutorials, I suggest you send me a support request, and I can take some time out and create a simulation, create a video, and help explain it a little better for you. Okay? Well, thank you for watching this very lengthy tutorial.